Actually, you know, I found comments in my code. I was amazed. Yeah, yeah. And I said, my God. So, you know, there were two goals. I said, I want to do really create a customizable implementation. I wasn't trying to do a new design. Okay. If I'm a researcher trying to publish research on something like this, I would do a new design, but it's almost impossible to publish something on a remote position call at this point. Okay. The fruits are very high hanging. So we went and looked at, we looked and said, you know, let's, as in a class at least, let's go and redo the design. And let's try to understand what's going on in the design of these systems in general. Okay? And I think what we've got is, you know, let me know what you think afterwards, but I think it's a pretty decent design. Okay? And, but let's now look at the, okay, which is extendable implementation. And, you know, sometimes the theoreticians are supposed to be the rigorous researchers, and the systems guys, the not so rigorous ones, because they use words like extendable a lot. And sometimes people don't know what that really means. Often people don't know what that means. So the terms the systems guys tend to use are often buzzwords. And you go to businesses, they use these terms a lot, in fact. And sometimes systems guys are more like that than the theoreticians, who are very clear about what they're doing. Okay? So let us be clear about what this extendable might mean. So in what sense is GIPC extendable from what you've seen of it? Actually, you haven't seen any extendability, but you might.
It's abstract, so it can cover a wide.
Okay, so that's one thing. Its design space is so large that you know you can use it to teach a lot of concepts. But extendable means what in English? It means that you can change the design space. You can do greater, less, whatever, right? So it's open source. I create open source code. I don't comment. Am I done? I put almost no comments, okay? I'm still going to lower your expectations so that you're delighted when you see comments rather than mad at me when you don't see comments. Am I done?
Well,
I'm not going to comment. So you can't make me comment, okay? What else can you make me do? That I won't do. What else can you make me do?
As far as like extensibility, ideally it would be helpful to not have to change the code of the thing you're extending.
Okay. So what is the term you might use for that?
It should be
Okay, so
flexible. Right?
flexible, but that, you know, but you're saying change without looking at the code. That's one thing.
Yeah. So
And do you have any examples of such code? I mean, let's just see in the ordinary life where you don't have to look at the source code and yet you can extend it. Sorry? Subclassing. So if I was to just go and give you a bunch of classes, tell you what their names are, tell you maybe their function. I mean, I don't know if I can get around from comments there, but you can certainly subclass something I did. But let's say you subclass the class. I mean, what are you going to do with that then? Yeah, but then in your application, okay, so that's good. In my application, I can extend the functionality of GIPC. That's good. But I want to be more ambitious than that. That you change GIPC's behavior for her.
Wrappers.
Okay.
Well, no, you would make
That means
modular, so that way you could replace entire pieces of it.
Okay, fine. So I've given you the source code, right?
Right.
You can go and delete my file and put your file in there with the same name.
As long as it uses the same interface.
That's one way. That's good.
Wrappers.
Meaning, the subclass you create is not the class you create is not a subclass of something else, but has a link to that, has a delegation. Delegation other than inheritance. Okay, that's good. All that stuff GIPC is there right now. Okay, but all of that stuff requires comments to some degree. And ultimately you can't get away from comments. But okay, let's keep going along those lines. Can we go and have more modularity at a courser level than just each class?
Yeah, well, you could provide some high-level documentation.
Okay, high-level documentation, which is going against my brain.
Like change stuff at the package level.
So what other concepts do people forget about Java? When they build systems, they talk of chunks of code.
Yeah.
And those are called
Yeah, modules.
Modules, but modules, there's connections. This module can connect to talk to this module, can talk to this module. How can we build code that has got fewer connections than are possible?
Layers.
I can layer things. Okay. Okay, good. Now, how can I go and, taking my code and putting your file in there, I don't like that too much. Is there some better way to extend the code?
Yeah,
To replace the code?
you provide abstract objects which don't technically have an implementation, or you provide.
Okay, I provide you with interfaces, but then, and I say you implement those. But then my stuff, how did my stuff work?
Well, you have a base implementation.
Okay, good, but how do you change my base implementation?
You override your.
So then again, you made a subclass, you made my subclass, but see, the trouble with subclassing is, and this is where, the answer is going to be so obvious in the end. And the trouble with subclasses is that some class C that you're going to change with C2 is being referenced by a whole lot of other classes. How do I make those other classes refer to C2 now? Look at him.
Dependency injection?
Injection, okay, bytecode injection.
I mean, yeah, like I guess if you had some kind of like factory,
Ah.
that's how I would do it.
Why did I was looking at you?
Yeah, I wouldn't build a factory. I would use some kind of dependency injection framework, but that way, if all of your classes are looking for like interface A, and then you're injecting your default implementation, and you can go and say, oh well, like I'll implement this interface, and then I'll inject my customized implementation. So now everywhere that was using.
When you say inject, I mean, is that a technical term or is that an English term you're using? Because you can inject code into bytecode,
Yeah. Oh no, not like that. But it's like if you have a class instead of that depends on I don't know how to do this. Like if you have a class A that depends on class B, and instead of just saying new B in the class, you say takes a B in the constructor.
Well, so basically factory, right?
Yeah.
So we just have to use it right factory.
Yeah.
And we look into that detail. So when we go and do extensions, we can do extensions in many ways. Okay, we can replace classes, we can replace layers. Okay? I can just layer things so that at least you see things one at a time, even if And is there any other extendable mechanism that is even as old as Unix that is so wonderful?
Something with pipes.
Can I interpose
You can,
things between existing modules?
Something like hooks.
What are hooks?
Programming hooks where you provide empty spaces that can be fast.
now,
So think of it that way, that I really provide some kind of hooks to add things in between two modules.
Yes.
So producer-consumer situation, I've got a producer, I've got a consumer, and I let you go and interpose a bunch of trappers in between. So for instance, I will delay something. My system is not meant to delay. You go and add a delayer somewhere here. Or you add a timestamper at the sending end, and you put another timestamp, a timestamp reader at the other end. And I can anticipate all these things, but I say that, I've got these layers, and you can put whatever you have in between these things.
Well, it's much like your launcher. You provide methods that we can put in there and technically empty under the hood.
See, the launcher is actually overcoming the problem of all this extensibility. It's saying that, I'll just make it easy. For the easy things, it's doing some composition by default. Okay? And by the way, how many of you have written an Eclipse plugin? So I don't know these plugins. I ask you this question because I don't know the answer to how they're done. But from what I understand, you can just add observers to the Eclipse events. Okay, so one of my students has added an Eclipse plugin where he just gets to know what commands the programmer is entering, and based on those commands, he does some data mining of that and figures out if the person is in difficulty or not. And so I can get to know how hard my assignment really is by going and seeing how often you guys were in difficulty. And if you weren't in difficulty enough times, I have to go and increase the difficulty level, right? Or I can actually help you. I mean, that's a possibility too. So we want layer design, and I'm going to say layered within quotes because this, I mean, I went crazy trying to do layering here because things just can't be layered. Okay, and there are multiple dimensions here, and pluggable. So what you really wanted was, replace my component with another component. So we'll just call that as pluggable. And okay, here's the other thing. Pluggable has got all these things, replacement, injecting, and all that. I want comment because I'm going to write each module is going to be just so simple that it doesn't require comments by default. That's the ideal thing. What is hard about GIPC or about any big piece of software is figuring out how to relate to each other. Okay, and some of you, what have you guys done? When you figured out what was going on, you just put the debugger, and I'll just step through it and see what happens. To me, that's the most reliable form of documentation. I don't have to go and rely on you saying this is what's going to happen. I can just see what's happening. In fact, when I did my PhD thesis, I worked on Xerox computers, and my bad habits come from Xerox. Xerox, the whole operating system that was in source code, not a single line of code, comment I found. And I never missed it. I didn't need it. They had lovely names, and I just put the debugger on, and I saw what was happening, right? So we're going to rely on tracing the program. Okay, and we're just going to make that easy to trace. We won't rely only on debugger. We'll go and do other things to it to allow the real algorithm to come out. The real algorithm, not what you thought you were doing. Okay, because the trouble with, when you don't know what you're doing, which is what's happening in GIPC in my case, commenting is silly because I just keep changing my mind all the time. If I've got Unix and I'm going to make a copy that's open source and call it Linux, I know what I'm doing. I can comment everything because I know this is what Unix did, this is what I'm going to do. Yeah.
But if your system's pluggable and you keep changing your mind, could you just making plugins for your system?
So the thing is that sometimes what things can be replaced? Okay, ultimately, when it's replaceable, it's not completely composed from scratch, right? There are some assumptions made about the framework. Then you say we can change this part of it and this part of it. Okay, so we're going to see all this in concrete. I'm not just talking, in big words here. Okay, but that's what's going on. And first, let me tell you what problem I had with layering. And I really went nuts here. Okay, because what are the layering dimensions here, by the way? Can you see some layers based on these types here? On port message kind, can you see some layers based on that?
Like buffer is lower than object. Object's lower than RPC.
Right? Can you see layering here? Right? Group is more than duplex, duplex is more than simplex. And who knows what's going on here? Okay? Client, server, session, multi-server. And the reason is that you can't order client and server. Okay?
You can also make the argument that each enumeration also represents a certain layer too.
That's multidimensional.
Yeah.
Okay? So when it comes to interfaces, I've got this multidimensional layering. When it comes to classes, I just kept changing my mind again and again, because I had to go through a linear thing if I'm using subclassing. Okay? I've got byte communication, object communication, no procedure call. Okay? And if you actually follow trace your calls, you'll see that you go through RPC, then you go through object, then you go through buffer.
Yeah.
Okay.
You go from simplex into duplex too. I think.
Yeah. So
I stepped through one this morning on the client and the server, and just went all the way down, and then waited for it to flip over to the server, and then went all the way back up.
So there were these layers. I mean, even without comments, you were understanding something about what is happening with these long names, right?
Yeah, and the debugger.
And debugger is wonderful.
Yeah.
I mean, when I look at C code, I honestly ignore comments. I just put the debugger on and just go, what's happening? And I've looked at I've studied, by the way, I've gone and studied many open source software systems in the last summer, and they didn't have comments. Or if they had comments, they were so long that who's going to read them? And it was
But it's kind of useful with all these documentation.
Java doc.
Java docs, Doxygen, and you can put in comments and just generate nice documentation.
I know, but who's got time to read that? I mean, if I go and see a method header, I'm going to look at the names and figure out what's happening. And when it doesn't happen the way it was supposed to happen, I'll go look at the code. I mean, it just takes too much. Scanning is such an expensive cost operation.
It's more helpful when this stuff is
It's obscure.
it's closed source, yeah, or There's no other document.
No, there are subtleties. There are boundary conditions in many
Boundary
cases.
conditions.
Absolutely. You need that. You need it there, right?
Especially because
Yeah. And that is a symptom of maybe a call that is more complex than it should be. Sometimes. Okay? Sometimes it's just because it's a powerful call. Okay? If it's a regular expression thing, you really want the calls. Okay. So you have, so you have some layering here. You have some layering here. So there's simplex, duplex, group. Okay. And here what I did was I had server port, client input port, and then there was session port built on top, which is basically there's no client or server. We are just talking all to each other. So there is some kind of abstraction here. And these are all in interfaces. Okay, in the implementation, I really don't remember which way I followed. Okay. Okay. So that gives you some method to the madness, that there is some organization. Okay, so we've got this layering thing done. Okay, and that's a very cool. So one is you add observer. Okay, and from what I've understood, that is exactly what, that's at least that's one functionality these things give you, Eclipse gives you. Okay, you replace existing layer. So when you see extendable Chrome, what does that mean? Have you guys ever seen, have you ever gone to the extension tab and seen what extensions, so what kind of things have you seen there?
Well, I know that some applications like to add extensions like Skype. Right? So
Okay.
It just adds functionality
Or maybe it replaces your search,
with some others.
or it replaces your PDF viewer tool. Okay? And these are things you see in operating systems also. In operating systems, what are things that people replace all the time? What are these things called? Drivers. Okay? You replace drivers, so we have to do something similar to that. My driver is executing other than your driver. Okay? And a lot of bugs happen and security issues occur today because drivers can be changed.
Actually, I know while I was working on design, my video driver was interfering with my DNC server, and it was causing my computer to restart every 15 minutes.
But that was at least a feature kind of thing. It was not a malicious,
Yeah.
okay, which happens by the security guys have to worry a lot about drivers being changed. Okay, and then there's interposition of layers between. So we have all of these things in GIPC. Okay, and when I ask you these questions, I mean, some of you at least have worked in industry, and like I said, what do I know? I looked at Xerox code, I followed that model, and that's what so tell me how things would be better. Add observer. We know that GIPC is based on the observer pattern. You can observe every little message receiver there in the world and say, aha, what's happening? If you can get access to it, which you can, you start with your port and you can get to its next port and so forth, and you can add observers anywhere you want to figure out what GIPC is doing. Okay, so that's a no-brainer given how we designed GIPC based on the observer pattern. Every time a message is sent, it's announced. Every time a message is received, every time a connection is made, all these important events you can listen to. But you have to find the right module, which is a pain. And I will tell you how to overcome that problem. By the way, how will you overcome that problem? Let me jump ahead.
Control-Shift-T in the queries.
So Control-Shift.
Control-Shift-T is the type finder. So you just start typing.
Oh, is that what it is? My fingers know it. I didn't know it was.
Yeah,
No.
Control-Shift-T, and then you just type.
No, finding all references is T, huh?
Oh, Control-Shift-R will.
Control-Shift-R.
HTML files, it'll look at every file.
Yeah.
Control-Shift-T just looks at the Java types.
Oh,
That's
okay.
all.
I always use R. Okay.
And then find declaration and find reference.
So you do that. But is there some better way? Is this a better way to sort of get the events you can imagine? I'm going to come to this later. Things are too distributed. I have to go and set myself as a registrar of every little thing there. We need something different from an observer.
Well, the way C# does it is they define an event in the object that will fire the event.
Fine. And so how do I find the firers?
Well, you just do whatever the object is, dot, and then you can get a list of.
I know. So it's the same thing here. If you can find the object, you can register yourself.
Well, no, it's like if you have object A that can fire event X, Y, Z, it tells you what events it fires.
So what is the it?
The object itself.
Yeah, so that's observable
So
object. That's an observable object, okay? And I, as an observer, have to go and monitor each one of you.
Well, what I'm saying is that in Java, you have to add a listener.
Yeah.
You have to know what the listeners are. So you need to know a wide array of objects, where in C# you only need to know the one object
That has all the events?
that has all the events.
Yeah, like in C#.
What is it called? What's it called?
You define public event something, like maybe mouse click or something, and you add a delegate for that event.
Basically, the language is aware of observers and builds them in.
So I as a user, it's aware of observables, right? I as an observer will contact what object to get all these events?
Like if you want to know that an instance, like there's a button class, and you want to know that you created a button instance called BTN. So if you want to know when BTN is clicked, you just implement, like it's a common method signature, and then you just do handles btn.click.
And all the button clicks from anywhere in the whole application.
No, just for that instance. But like there's the thing, the language is aware of the observer pattern, so it knows like, hey, I need to wire up this class to listen for the
Fine. Okay, so the wiring is made easy, right? But I want to know, how do I get to know all the events in the system?
Well, they're exposed by the class.
So I have to go to every class and listen to the events?
Yeah, you look at like if you want to know what events button exposes, you just go to button and it says clicked, release.
So somehow I'm belaboring the point a little bit, but somehow if I want to listen to events, I have to know the object firing the event. Somewhere or the other I have to tell them. Somewhere it has to be indicated whether I go and explicitly do this or somebody goes and connects me to it. Somewhere I have to indicate which.
Yeah.
So I have to know. As an observer, I have to know the observable I'm testing.
Right. Yeah.
So this is too distributed, is what I'm saying. I want a bottleneck. I want a central authority. What?
You want a message bus?
You know about message bus? Where did you learn message bus?
I learned it specifically.
Okay, good. Excellent. I was trying to derive the concept of a message bus.
Oh,
Okay? Invented by a guy called, you know who invented that?
message bus.
Yeah, a guy called Steve Rice at Brown University invented that idea.
But I thought in distributed systems it was to avoid the bottleneck, so I didn't say message bus.
So basically you want a bus-like thing, just in hardware. You can just tap on the bus and to see what's going on. You don't have to go to a device, this device, and say, I want to listen to you. This device, I want to listen to you. You don't even know what the devices are. You just say, whatever's coming here, I'll figure out which events I want, which one to do. So everybody broadcasts to the message bus, and then you have listeners from the message bus. That's a concept there is here. I call it a traceable bus. We'll see why that is. Okay? So that's the kind of functionality we're going to have. Okay? So, by the way, replace example. In my case, the drivers are these lower channels, whether they're NIO or they're sockets. So there's socket driver. Sorry, this is, there's some type. Yeah, that's. So we have the socket layer underneath, and there's some typo here, and we have the socket layer here, but there's some drivers to these, and these depend on the underlying layer. So I want to replace NIO with sockets, perhaps, which is something which was one of the assignments I've given, which I gave 2 years ago when I taught this course. Okay, so this is an example motivating replace. Okay, and we are going to use factory-based instantiation. Okay, so we're not going to do new directly. We're going to do new through a factory. Okay, so we can have one factory, another factory. Okay, now comes the problem. How do we specify to the system which factory it should use? We have a level of indirection, that's good. Our program is not bound to a class, that's fantastic. It's bound to an interface. By the way, factories and interfaces go together. Okay? And
That's how we would judge dependency. Like, if you were talking about coherence, it was like you look at the news in the class. And if you do a new whatever, then you have a very strong dependency. Or if you have a factory.
No. Dependency is one thing, but I'm just saying, given some set of dependencies, I want to replace one module with another module. How do I tell the system to use this factory or that factory? The guy who's instantiating that thing is not doing it directly, so that's fantastic. He's not binding himself to a new class. Okay, he's saying factory.create, okay, which does a new, and this factory will do one kind of new. This factory will do another kind of new, based on the class. How do we choose between these two factories? How do I tell the system use this factory rather than this factory?
If the system solving the system, that there's a factory and a non-factory, we can use reflection.
No, reflection means understanding what a program is doing. Here I have to specify to the system, I want to do this.
So when you initialize, you need to pass to the framework what.
So somehow in some configuration. Okay, so that's interesting. So factory instantiate is a set of rigid types such as ports. Okay, and you guys might have seen some factories if you've been looking at the code there. Static methods. So this is my example of a factory before I go to that. This is my interface, which says create this kind of port, client port, create this kind of server port and client port. So a factory can create more than one kind of object. And we know that the client and the server port have to be somehow matched. Otherwise, things are going to go crazy. Okay? So we'll provide both methods in a factory. That's an example of multiple objects being created by a factory. Okay? And now I have to go and choose. So then there are these two factories, a socket factory and an I/O factory. Okay? So we have two implementations of this particular interface. Okay? That's just an example. So that's what you were saying, some kind of static method, some kind of, I can have a global registry, okay, where it says, this is my, and it has these static properties. This is my factory for this function, this is my factory for this function, and it has setters and getters that you can call to go and set the thing, right?
This is just like dependency injection. It's like, yeah, it's like you replace all your factors with the dependency injection framework.
You love this word, dependency injection.
Yeah, because that's what you do. It's
But
just,
why do I have to use these big words? I'm just saying I'm replacing one kind of object with another kind of object. That other kind of object better follow the dependencies of the first object. I'll grant you that.
right.
And maybe if there's a framework, I know whether I've got the right object there. Maybe that is what you're going to help me with. Okay?
Yeah, I guess.
But all I'm saying is that once you made the decision using your framework or whatever, I'm going to replace one object with another object. And this factory could be my socket factory or my NIO factory, and I just gave you some concrete examples before that. There was nothing interesting there beyond that from this lecture's point of view. And we can just have this. Okay? And I can also go, and it has a link to all factory instances, and we have static method to change and get references. And I can even create a little specification file, like a configuration file. I mean, this is what happens in operating systems, by the way. Huh? That there's a file that says use this driver, this driver, this driver, this driver. Okay? So I could have a file.
Yeah. It's funny because like in Spring, you have an XML file, and
Yeah.
you can create the objects from XML, and then you can say like, oh, send message, let's send it like use an email sender. And then you can be like, oh, let's use a text message sender.
So see, I discovered, what is Spring?
A dependency injection.
Okay. I was wondering whether you can go 5 minutes before I use the word.
It's like,
That's once.
it's the handiest thing. You just like, all right, let's just pick a new class.
Okay,
and
so
just
I did it last year. I did this 2 years ago, and I'm saying this is a lousy idea. This is a lousy idea. I suffered a lot because of this reason. Why? I have the word. What is a really bad word here?
Static, global.
So is static bad, or global bad, or factory bad?
They're both pretty words.
Okay, static is worrisome, and actually that was an issue for me also.
Registry, if you're a Windows user, it's like all
But
that
global,
stuff is kind of-
global, this was a system that was evolving. And what used to happen was I would give them these 10 classes. Then between this assignment and next assignment, I'd add some more objects. And I have to give them a new version of the static class. Then I added some more things. Actually, it was the other way around. I had these things, and I was taking them away from them. So I had to comment out these things. Then I had to comment out a separate set of things, because I didn't want them to see the whole system. So this was way too central for me. Okay? So what I did was, must change registry each time a new port is added, okay, or exposed is what was the case in mine. So then what I've got is now still static, and that created issues for me, creates some issues also. But I have factory selectors that are distributed. Okay, so for each kind of object, I have a separate factory selector. Okay, So let's say I have a factory with a create one method and a create two method, okay, which implements this as an interface. I will create a factory selector with static method just for convenience, because then how you know, without static methods, the question is how do I get a reference to that object in the first place, okay? And it is going to have a set factory and a get factory. And that is enough, right? Because I can go to the selector, I can set my factory there, and then we can go and get that factory and then use the factory to instantiate things. But just for convenience, and this was something actually I'm not very happy about because maybe do a lot of work, this instance method signature I would copy in here and make it a static method. And I would have the static method say factory dot instance method. So I just made static methods out of these things so that you don't have to say get factory dot create. You can just say create, and that goes to the factory and calls create. Yeah.
So the factory selector has essentially the same interface.
So the factory selector, because the static doesn't have the interface, but has a static interface, if you will, essentially. And this is painful because every time I change this interface, I've got to go and change this back. So in retrospect, I don't like this decision, just because it's changing things a lot. But it certainly makes my calls much easier. I don't have to say factory dot get factory. I mean, it just becomes very long. Okay, so that's just a detail. Okay.
Look at the abstract factory pattern.
Isn't this abstract factory? A factory that creates factories? I believe the abstract factory is a pattern is very abstract. It never says what we should really do there.
Yeah, it eventually gets down to, but you end up with a lot of classes.
Okay, so I do. And if you'll notice, there are all these selectors. Okay, if you might have seen there, I've hidden that away from you in the port launcher. But there are these selectors you use to create things. Okay. Okay. So abstract factory provides static versions of factory creation methods for convenience. And so this is essentially abstract. So here's a factory, that's just an example. And this is the byte buffer factory. So this is just showing you how that example I showed you, change the NIO with sockets works, because you just go in the selector, assign to the selector a different factory object. Yeah.
So not only do you, if you change the factory method, you have to change the selector, but then you have to change all the other factories you created as well.
All the guys who are using that selector?
Right, because you have different factories, right? Or is it one base?
No, if you change the interface, the method signature, I just do refactor. Okay, and all the other factories are the same method. But that refactor doesn't go to the selector. So that I have to do by hand. Okay? So that, I don't know, that's just a very small detail, but it cost me a lot of. So you see here that I'm saying selector.create server simplex input port. That's all I'm saying. And based on what factory is assigned, I will either get the NIO version or the socket version. Okay? So this creates the same selector is being used to create both the client port and the server port so that they come in pairs. Okay? Okay. So how to assign factories to selectors? Now we've got to do that. Okay? And sometimes there are set of factory selectors that have to be changed together. Okay, so there's yet another level of interaction. And you can keep going berserk here. Okay? I'm just saying that I had to use this third level because you have to set related factories for each configuration. And I have something called a port launcher support, which now is an object. Okay, so I finally get to instance methods. And the port launcher support is something you come with each port, and it sets all the factories relevant to that port. Okay, so that's what this support is. And so the supports are where all these select calls are made. And you just go and say, hey port, selector port, set your factories, and all the relevant factories get set. Okay, and you just say init, and it'll do that. In fact, I just added another method to the support yesterday, but otherwise this is what it really does. Okay, and there's some tracing stuff also you can do. So before a port is called, the init method is called on the support, which is supposed to go and set all the factories for that port. Okay, and this way you get the right factories. Okay. And by default, the init method sets the factories and sets tracing, and we'll see what tracing is soon. Okay. And just to clarify things, there is port launcher and there's port launcher support. Port launcher, what you guys are using, and there is a method called get port launcher support for various kinds of ports you might have, the auxiliary port, the main port, the tertiary port, whatever. So there is this get method that's not exposed to you directly in my examples, but that is a method there that goes and decides which support you use, because you can have one support or the other support, okay? Depending on which port you are using. Okay? So when you launch, it uses that. Okay. So we figured out how to add observers. We know there are observers everywhere. We know how to replace an existing layer, and we've got these multiple levels of interaction. But the main point is that you don't want to instantiate directly. Interpose new layer between two existing layers. Okay. So interposition motivation, I've got all these layers built in. And what if I want to add delays with message, for example? This is what I said. And do not want to duplicate code in different drivers. So I don't want to go and add a special kind of port that does delays. Because then if I have a socket port, I have to add delays to the socket port, plus I have to add then I have to add delays to my NIO port. I want to just go and see the messages that are going to this one of these two ports and add delays right there. Okay? So this thing I added after I designed the first version of GIPC, so it's kind of hacked, but still it works. It does work. So sometimes, and this is pipe-based extensibility. The idea is that because we are in a distributed system, okay, there is always producers and consumers of information. Okay? When I send a message, the application is the producer, and my NIO layer is the consumer. When a message is received, my driver layer, NIO socket, is the producer, and my application is the consumer. Okay? So I will go and just go and add pairs of these things, so that when I add some layer here, it becomes a consumer to this layer. So this layer doesn't even know the difference. And then it's a producer for the layer below it, and so forth. Okay? That's the basic idea. Okay, rest are details. And you see many kinds, and there are two kinds of these things I had to do. One is a producer. One is a proxy that has, so if I say proxy versus translator, what does that mean to you?
Proxy doesn't do serialization.
So proxy by definition is what? When you see proxy is a very generic term.
Proxy is dumb.
Just like a pass-through.
It's not so dumb as it's just uniform. Whatever it got, that type of information, the type of information it produces is the type of information it consumes. It could do interesting things. I mean, there are caching proxies. You won't call them dumb. They really improve your performance. Okay? And then you can have translators that take one type of object and translate it to another type of object. Okay? So the serializer that your code will run through happens to be at one of these things. Okay? It's one of these interposition things. And it just happens to translate. And then the delayer would be more like, the delayer may also go, the timestamper will also be a translator. It'll take a message that's not timestamped, make it a message that is timestamped. But a delayer will just take the message it got, produce it, and add delays to it. Okay? And the thing I found, which is where it became a bit of a hack, was sometimes these two pipelines have to be connected. Can you see why? And this example might tell you. So even forget this, when you're timestamping, one guy is adding the timestamp, the other guy is removing the timestamp, right? So they're related. Plus here, for, one guy is going and sending a message and blocking himself. The other layer is unblocking the guy. So there's a queue that is shared in between. Okay, so when you guys, get into deadlock situations, if you guys get into deadlock situations, you will notice it's because, this guy is blocking on something that never came and not being unblocked by something that came. Okay, so just want to indicate to you guys that this thing is not as independent as you might think. Okay, that sometimes you need things to be synchronized. And then what happens is, how do these two guys get connected? Some factory is responsible for instantiating both of them, that factory creates a shared data structure and then passes it to both of these guys so that they can have the same shared structure. So factories are good for many things. Factories are good for changing your mind, but also for taking a bunch of objects and letting them share some data structure. Okay, that's fine. Okay, so my send trapper, and here's an interesting thing. My send trapper is something that is an extension of a naming sender. So unique naming sender is somebody that indicates a unique destination for a message. Okay? And my trapper is also a producer, is also a consumer. It's also a producer, so it also has the same interface. It can also send. Plus, it has a destination. Okay, so it knows who to send it back next to. That's a property. And the implementation of this send trapper basically implements the send trapper and also has a reference to this guy. That's the interesting part here. That it implements the same interface. It has, and that the interface it implements is also implemented by the object it refers to. That's what a trapper is, right? That it's just passing the message to somebody else, so it has a reference to somebody else that implements the same interface that it does.
And that's how you can kind of like fake out some runtime inheritance, because you can pass a reference to the thing that if it's implementing that interface, and you decide at runtime like, oh.
So this is in chains. This is to create chains, basically.
Right.
That's what, for a chaining, that's what happens. Okay, that you have a reference to an object that is a type, your type. You can always replace is a links with has a links. This is a special kind of replacement. Okay, it's trappers. So the receive trapper is all receive trappers are notifiers. Okay, they don't just send message to one end, they go and just notify anybody that is observing. So when I go and attach my own receive trapper to another receive trapper, I have to notify all the objects to which the other guy would have notified. Okay? So if I really want to sort of, or sometimes I do, sometimes I don't, but they both are capable of notifying and having more than one sync. Okay? And how that's done is, I won't get into that. Sometimes you replace, and sometimes you. So debugger is a great tracing tool. Why do you want anything else?
Maybe you don't have a debugger available.
Maybe you don't have the debugger available. Now, who's...
Maybe some of the source isn't available.
Okay. Maybe some of the source is not available.
Timing. Unless you're trying to like
Okay, timing.
intentionally hold the server up to replicate a delay.
So timing, race conditions.
Yeah.
I can't tell you how many times it worked with the debugger and it did not work when it was running. Okay, you guys will face the situation. So with GIPC's case, we have the source code, we have a debugger, but that is the issue. Any other reason?
The debugger adds a lot of overhead.
So it slows things down. So who's doing the tracing here? Supposing I wrote GIPC and you did an assignment. Are you tracing my code? Am I tracing your code? Both? What's going on here? You may want to trace my code for sure, right? And what goes on with the debugger? I figure it out today. 2 months later, I got to go through the debugging steps all over again because I never wrote it down. That's what I get for not having comments.
Good for like logging.
So you want some logging, right? That would be cool. And whatever comment you would put in a comment block, please put that in a log. I can read the log statement as well as I can read the comment. And the nice thing is, I can see it at runtime. Right? And then if it's a log, I can go and see what you guys did. How do I know that you replaced my serializer with your serializer? Nice demo, it all works. But if you run it, and the logs show my serializer running, okay? So one of the things I will be telling you guys to do is go and put these tracer statements in there so that the tracing is on. and I can see what really happened. And you can be sure. Okay? So debugger makes it difficult to test race conditions. And you know, with the debugger, at least the one that comes for free from Eclipse, you know, everything is mapped to a single code window, so I just have to keep shuttling between windows, which I don't want to do. Cannot see the history of actions. Okay, so you have to just breakpoints do not transfer to another computer. Okay, and you know, cannot use a mechanism to set multiple related. You know, I can't do it from the program. I can't go and say trace. Can I? Actually, some debuggers might allow that. But please trace this method and have some runtime parameters that go and change things. You have to sort of set it before running, at least the way I use it. I'm sure there are advanced debuggers. I know there are debuggers that have conditions associated with them.
Yeah, I mean, you can set breakpoints at runtime as long as you're in debug mode.
No, but you meaning what? As in a program, can I write code?
No, I don't think so.
Okay, so the debugger doesn't have an interface in a program.
Right.
So am I going to fix these problems? And so the solution I'm going to present to you is pretty heavyweight, but it evolved. I didn't just plan on it. And it's going to allow these things to. It's going to allow you to have these features. And here's my trace. Okay, so you type in the words are lovely, and or you've got echo, and it shows you, you know, all my trace statements. So if I may not have many comments, but I do have many trace statements. I don't have enough of these either. Okay, but you didn't see them, right? When you guys ran your programs, you didn't see any of these, did you? Did you see them output?
When it dropped messages. Yeah, when it dropped messages.
Just warning.
That was just a warning.
An error.
Yeah. Yeah, there's no E here. There's all I. I is for information.
Yeah. I saw there's no code while I was stepping through stuff.
Yeah. But
The trace level.
is the warning. W is the warning. E is the error.
Okay.
And I is the information. Okay, that's what I'm really concerned about right at this point.
You can turn the eyes on and off.
Okay, so you can turn it on and off, and that's a very simple call, right? Tracer show info true, tracer show info false. Okay, that's something I came up with 10 years ago. Okay. Anything else you want here? Any other kind of turning on and off?
More things.
Okay, so that's tracer show info true false, tracer show warnings true false, tracer show error false true and false, tracer set level 1 2 3 4 where error is, you know, higher level than warning and so forth. Okay, so that another student of mine, Sasha, put in a long time ago. Anything else?
That's a mistake.
Sorry.
That's a mistake.
Okay, so we need some state. That's a little advanced feature.
Filter.
Okay, so what do you want to filter on? Let's see.
Keywords. Subject.
Okay, so I can say tracer show info for all messages that are registered with this keyword. So when I say tracer dot log or whatever that thing is, I will go and give a keyword saying this is the kind of message I'm printing out, and I will go and say here's the message.
The keyword is just a substring.
Is a string. Is some kind. Okay, so you can do some regular expression matching there also. Okay. For now, we'll just say the keywords have to match. Okay. Do you guys like the idea of setting keywords? Each time you go and set your log, you have to associate that with keyword. So what kind of keywords might you use in practice?
Module name or package name, because maybe you're interested in only a particular module. Maybe one module is failing and you don't know why. So you
Okay.
get all the information.
So do you know anything in Java that says do this for this class or for all classes in this package?
Yeah, there's a get package call.
No, but in Java, you're saying you can do that, but have you seen any feature that Java gives you that filters based on class or package? I taught this stuff in 401 today, so it's all fresh in my head.
Android debugger does that.
Yeah, but the Android debugger just gives you everything.
So-
and it's
Yeah, but
like
then you can
filter
Not
all-
debugger. I'm just saying, don't even think debugging right now. Well, actually, it's related to debugging. But just think of any feature of Java that is turned on or off for a whole class or all set of packages. So you guys haven't seen this, and you probably haven't used it either. So when Java was invented, right after that, I went to a conference where James Gosling gave the keynote. And he was asked, what's the biggest mistake you made in Java? And he said, I don't have assertions. Okay, so then assertions came 1.4. And assertions you can turn on and off. Have you ever seen how they turn on or off? For you can say tracer assertions minus EA class name or minus EA package. Okay? Okay. That's one kind of filtering. Do you like, what do you think is happening here? My message is being printed, and before the message, what is being printed?
Package or the class name.
It's package. And what else might you want here? Or maybe the full class name? That's it. So these are the options I give you guys. Okay. So you say tracer.showInfo true. You may not want to know about NIO. Okay. You guys are not dealing with NIO. You just hope it works. And so I'm only printing messages that have to do with input port.datacom, that's simplex or buffer. See, I've got the filtering right now. Only for this package. Okay, that must mean that I have some way of saying only show things. Okay, so I can have keywords. I can say, and by the way, this exists. I can say tracer.info, here's a keyword, here's the info. Here's the information. Okay, so I can say tracer.info, input port.datacom.simplex.buffer, the package, asking driver to connect and change status. Okay, and then we can set keyword print status. I can go and say, here's the keyword and here's Boolean status. That means for whenever all messages that are tagged with this keyword, show them or don't show them. Okay. And you guys said you didn't like that, right? So what you would want to do, so how, yeah, we want to filter by packages, but how do I in my info give the package name automatically? How can we derive the I don't want to specify this name because when I refactor, I've got to rechange the code. I can certainly go and set the keyword print status by package name. There's no problem there. Once I get the right package name here. But how do I derive the package name automatically from something that the program has a handle to?
You do class name dot class dot get name, and it'll give the full name package.
So I go and say my class. How do I go get my class?
You just do
How does when I put this tracer method, I'm in some method in some object.
Yeah. Normally what we would do is at the top of the class you have a static field called tag, and it's just a string, a final string, and you do set it equal to, like if you're in the class person, you do person dot class class dot get name,
Okay.
and then you would just use the tag in that spot.
But if I refactor person to something else, you're saying the person will also change there?
Yeah, person is also changing. It's like it's the Java class name.
Okay.
And so then the string it would output at runtime would also.
So by the way, there's something called all keywords, and you can say all keywords false. Okay, that means by default all keywords don't get printed out, and this particular one gets printed out. So how to specify package name each time? So what we'll do is we will just give object here. Whenever I say tracer.info, I will just give myself some object here. From that object, I can derive the class, I can derive the package, and so forth. Okay, and saying, here's the status message. And I can say set keyword print status. And now, when I'm setting the status, I don't have an object at hand. That's something I'm setting in some global thing. Here I am in some method in some class, so I can say like this. Here, I want to do it for. Might not even have an instance. So I'll just give a class name from which the package can be derived. Okay. So I can just say something like this, which is like what you were saying. Let's give the class name and do it. Okay. Now, what kind of call? Now I need a call to go and change maybe from package name to class. Okay. So we figured out which events we want to filter out. We're going to use we can specify any package. Okay. And now the question is, what do we display for it? Here what I want to do is maybe print out not the package but the class name. So I need another dimension, and that is my message prefix pattern. Okay, one is my keyword. Okay, that I've got this particular. I'm setting. There is a notion of a keyword. We know that will filter out messages. Here I'm saying what kind of message prefix to use. And here the message prefix I'm using is a package. Right? And I can go and, I know I'm out of time, but I can go and say short class name. Okay? And now I'm seeing just the class name. I'm not seeing the package name. So this is not something fundamental. We wanted this. This is just the API for it. Just quickly. So my message prefix kind can be either the package name, the full class name, the short class name, the object's toString, okay? Or it can be nothing. Okay? And now I told you that in assertions you can either filter by package or by class or by something else. There's also implicit keyword. What if you want to? So now I'm only seeing events related to this particular class. This is like my assertions I was talking about. Not every class in that package, but only this class. And that is just another option. So that is implicit keyword kind. So what is my keyword going to be implicitly? Okay, I can always say explicitly this keyword, or I can give myself as an argument and say this. And then the question is, what property of that object should I derive to use to derive the keyword? It can be the package name or the class name or something else. So there are two dimensions. What prefix I show and what property of the object I use as the keyword. Okay? And this is the message. You see this. You can say object toString, class name, or package name. Okay? So what I told you earlier, we want an abstract. These details tell you how to get it. Okay? And I don't know what is hard and what is easy, but I personally think that this current assignment may be the hardest one. If you've been having trouble with threes, I mean, the nice thing here is that it's not this very big distributed system. Okay, it's just an algorithm. This two recursive algorithms, right? Okay, so that's the good news. The bad news is that the recursive algorithm has lots of objects involved in the algorithm. Okay. So it's not easy, and we're running out of time, so I'm just going. Okay. And I want you guys to go and demonstrate the working of your algorithm somehow. And I don't if I'm not going to comment, I'm not going to require you to comment. And like I said, I don't want to really look at your code. So somehow how your algorithm should be evident from your runs. Okay? And that is where the tracing comes in. That I'd like you guys to trace your calls. And whatever you would put in a comment, put in your trace calls as strings. And I can see the algorithm. I can see truth in advertisement. I can see that this is exactly what happens. And you don't have to give me an algorithm because the algorithm will be generated from your trace. Okay. So I need to tell you about trace, and I've told you about trace, and here's this. And I've told you. So you need to trace for me this project and the next project. Next project is a small amount of code, unlike this code, but having to deal with lots of things. Okay, you have to just plug in your code at the right place. And if you do it right, it'll work beautifully. If you don't do it right, you'll learn a lot about GIPC that you didn't want to learn about. But that will require you to do synchronization differently. Okay? So where GIPC right now goes and says, I'll just send the method across and hope the buffers don't get. By the way, please don't make your buffers in thousands. Okay? Make them in 100. I told you how to go and change the buffer size. Buffer pool, and don't make it thousands. That causes problems. I found that, and another student found that. Make it in hundreds, and that should work fine. Okay. Did you do it in hundreds?
Changing it to 500 precisely worked because that was the maximum number of messages anyway.
Yeah. So you're living dangerously. I would have done 501. It's one of those things. Can you guys see buffers leading to deadlocks? If you don't, you guys saw that the things just didn't go across. Can you imagine that if you don't have the right number of buffers, you could come up with a deadlock situation?
Yeah, it could be. So, let's say I've got one part of my thing doesn't want, is waiting for some message from another part of the system that I know for a fact that it will send it.
Yes.
The problem is if it gets dropped from a buffer with no notification, it thinks it sent it because it's asynchronous, and I'll just never receive it. And so I'm sitting here waiting on a response.
Okay, that's one way. Let's assume that the other side keeps sending again and again.
By the way, buffers are always full and it's always going to drop.
And why are the buffers full?
Because you're waiting on its response and you're not consuming anything. So it's
You have gone and said, you will release a buffer only if you get this message, and you can't get this message because you don't have a buffer. That's why you want the send buffer pool and the receive buffer pool to be separate. Or you want to have at least one extra buffer. Okay, but that's good. The 500 made it work. Okay, so you're going to have synchronization then, and I have to see that it's synchronous, right? Which means you have to show me that until you go and you'll have to show me. I mean, it will go so fast I can't see it. So you have to go and say, look, I pressed this button. At this point, the server has finished executing his call, and see now the client is unblocking. So you'll have to show me blocking semantics. And you can do that through debuggers. But that's you have to go and keep switching windows, and that's not the best way. So what I'll tell you for the next 10 minutes is how to go and demonstrate the second part of your project. Your third assignment, your last assignment, okay? Your fourth assignment. And this one, these things I already showed you earlier, we're going to, you use this for demonstrating your serialization. Okay? Because there's no blocking semantics here, so if you just give me a linear printout, that's good. Okay? And let me summarize what we did last time. We had a very generic way of doing, I can point here. Okay. So there was this tracer object with static methods, tracer class with static methods, and you can always announce some information and associate that with a keyword. Okay, and then depending on so you are the program writer, and you say this might be interesting. So whenever in doubt, you go and announce something with a keyword, and then the reader goes and decides which keywords they care about. So they go and say set keyword print status, and they go and say, okay, this keyword true, this keyword false, or all keywords true and all keywords false, and the specific one overrides the general one. Okay, so that's a general scheme, and that's a pain because we want to filter in some organized fashions. I want to filter by class or by package. So I want the key. So this exists, but I don't want to use it directly, perhaps. So I want some implicit derivation of keyword from both my info method and my implicit and this status. Well, I just want some implicit derivation, right? And for both of these methods. So I can go and say my implicit keyword kind is either the class name or the package name, okay? And always announce, so these three things should have been together. I can always say before info, not keyword by object, and say, please take some property of the object and use that as the keyword. Okay? And whether that property happens to be the toString of the object, or the class name, or the package name is something we decide via a separate call. Okay? This is sort of setting the mode, if you will, and saying, this is my implicit keyword, or something else is mine. So when I do supposing my implicit keyword kind is package, then when I'm doing info object string, info extracts the package name from the object and uses that as a keyword. If it is class, it extracts the class, and if it's toString, it extracts the toString and it just uses that as a keyword. That's exactly what's happening. You can go and, this is in util, you can actually follow the code in util and see what's happening. Okay? And when you go and say set keyword print status, now we are not going to say object, a keyword. We can say object, I don't know if I allow it or not, but typically we don't have an object at this point, so we just say class. Okay? And again, if the implicit keyword kind is class name, we will use the class name, or we will use the package name, and it doesn't make sense to you do toString for that, so that will be just MB. Okay, that will do nothing. And that is deciding which of the events I see information about. The next question is, what information do I see about the event? Okay? Clearly, I go and see, that's what's going on. Okay. I didn't have it muted, and I just kept hearing an echo back. I can just use my, so we are in info, and I certainly see the info string, The question is, what else do I see about it? And I can see nothing, or I can see the toString of the object, or I can see the class name of the object that was used in the info, or the package name. And that is determined by message prefix kind. Okay, so what information do I see about an event and which events I see? Yeah.
Is there any particular reason why you didn't allow multiple prefixes to be put in? So maybe like do like a, I guess, flag setup so that you could ask more than one. So maybe you want to see the full class name and the package name?
So you have some kind of, the way this would be done is to have, another option that says both things. And
Couldn't you do a bitmask for that?
so what would you want my info? You would want my info to change. Which of my calls would you want to change? Info, set, the implicit keyword methods, the status methods. Which one would you want?
Yeah, so prefix kind.
Prefix kind?
I mean, you could feasibly do it with implicit keyword too, but
Yeah. So see, in this example, your full class names gives you the package and the class name.
well, that's true. But maybe you want to see the package name
And the toString?
yeah.
Yeah, I never use toString. I would just put it there. I already think I did too much here. In fact, I've done more than I'm showing you. I just didn't want to, you can easily go crazy in these things. But let me know if you ever have a reason. I'm happy to go crazy. Okay, so everybody fine with this? You guys can go and put your info calls in your various routines in your classes and say, okay, I'm the bean serializer. I'm serializing a bean right now. I'm the string serializer. I'm serializing this. I'm in the serialization mode. I'm the deserialization mode. You can put all this stuff in, and we can then just go and filter by, we can just see your tracer message. And I'd like to see only your tracer messages and not mine. Okay, or maybe I want something before yours and something after yours to show that you are doing it within my system. Okay, so something like that. Okay, so that's. And this is what I might want in tracing. So for your synchronization demo, I want to be able to see your server and the client at the same time. I don't want to going and playing around with the Eclipse window and saying, okay, I'm running this now, look at the breakpoint here and so forth. Right? I want to be able to see your traces in different windows, which I've already told you how to do. But I want then for you to be able to block also. Okay, so you press a button and you say, now look, I saw this output. Only when I press this button, I saw this output. Right? So I want debugging-like capabilities without a debugger. And is it so hard to make something block and unblock using Java? No, there's no debug points right now. We are running things outside the debugger.
I did it just by having make a scanner on the keyboard and then just make it to where you hit type anything and hit enter and it'll go.
That's my Comp 101 solution. And I do use it there. Huh? And we did that, right? We did that also in in that, yeah. What's the operating system course? You want to do wait and so just want to use something like that, which is what we do. Okay? And because then you'll have a button and you'll say, so that's what you want to show off. I mean, those waits and notifies are good for something, right? They're in class object. Probably, if there's any one lesson you're going to learn from this class, it is that they are fantastic. Either Kevin didn't do his job right or I didn't do my job right. Okay. So we will just use something like that. Okay. I want to be able to see at that point, maybe, and this may be in the demo you won't show, but I just want to be a little ambitious here. Just as the debugger shows me at the breakpoint some state, I'd like to be able to see some state at each blocked point. That means when you go and give your info, you're not just giving me a string. Maybe you're giving me an object with some state that my system can then go and display and saying, this guy announces event, and when he announces event, this was the state. And I'm storing the state, and I'll just visually, I've got object editor, I can go and display anything easily. And I'll just show you that information. Okay, so not only we're going to do thread.wait and object.wait and object.notify, but we're going to notify not strings now, but objects with state. And these will be events that I can query at runtime. And these can be multiple ones can be around. So I don't have to go be at the current block. I can just go down the history and say, these are the 10 events that were announced, and I can go and look at the state of all of them. Okay? For debugging purposes, at least I found that useful. But for demo purposes, it won't be that important for you. But when we're doing this, let's do it right. Okay? Rob, you're very puzzled here.
So we're just going through. At some point, we put like the thread.sleep for like 10 seconds.
Oh, please don't do these things. 10 seconds, polling. You got wait and notify. Why do you want to use 10 seconds? Don't use time.
I don't understand why we're blocking in the system when, for demo purposes, we could just put a debug point and be like, all right, look.
You can't put, no, but if you do debug point, firstly, they won't transfer. What do I want? I want to see your demo. I want to run your demo too.
Oh, okay.
Do you want me to go and put the debug points, and then you want me to go and shuttle between, at least in Eclipse, I have only one screen, one place where I can see the output at one time, one place.
Right, yeah.
You want me to go and see there, that? Oh my God, what a pain it is. So we are out of the debugger. We want to do our own debugging, essentially. We are doing tracing, okay? And we're going to have a state, and we want to build our own state display mechanism, okay? So basically, this one says I need some kind of way to notify. Okay, that's what it says. This one says I want to announce objects with state rather than just strings and messages. Okay, in that state, part of the state could be the string message. Okay, and maybe I even want to see the whole stack trace. I want to see the stack trace at the point at which you announced an information message.
So we could just throw an exception and catch it and print the stack trace.
Excellent idea, except we don't have to throw and catch an exception. We just have to create an exception object. And whenever you create an exception object, the stack trace at that point is in that object, and you can say get. So I don't want to say not. So that really means my events that I'm going to announce are objects, and these objects are subclasses of runtime exception, because they're going to have that stack there. Isn't that cool? Why not?
So when we block, you're saying
We'll block with wait and notify. Yeah.
wait and notify.
Wait. We'll block with wait. Yeah. Which was your solution. So don't be too puzzled here.
No, yeah. What is this method? Is object.wait or thread.sleep?
No. Thread.sleep is what we don't want to use. Okay.
Okay. So
On any object, you can say every object is a monitor,
Okay.
and you can say wait.
Oh.
If you ever looked at any object, there's a wait and there's a notify. Okay. And by the way, that's something you guys need to. If you don't know enough about that stuff, please look at my handout from last time. Last semester, last time I taught this course, I spent too much time. Not too much time, maybe, but I had to spend a lot of time on threads. And that's what I've changed. That's one of the big things I've changed, because I said, well, you can figure that out yourself. Okay.
So just look at those notes on Piazza. Yeah.
On my web page about it.
Yeah, it was from that link you posted on Piazza.
No, the regular web page has probably got some background material at the bottom.
Okay.
Probably. Okay. Otherwise, you can look at the 401 stuff. I'm teaching threads right now there.
Okay. Yeah, I've never used the object.wait.
Okay, but that's monitors. Okay. Okay. And finally, I want to maybe just get to see the whole. I want to get some timing information, and I want to just go and see the correlation between various events and see, this event occurred before this event and so forth. And not, you can see through history, but I might also want to see all these objects. In fact, I might want a distributed system where I want to see, okay, when this guy announced this event, after that, this process announced this event, so I can see some synchronization between processes. I don't have the solution right now, but I've got everything towards it. And this is where I want a message bus. I don't have a message bus, which is what you were talking about last time, and we'll talk about that soon. But the idea is that we observe not various observables, but all the observables go and tell one central authority that something interesting has happened. And all the observers contract that central authority. So there is no direct link between observable and observer. We have a level of indirection. I know bottleneck is bad, but indirection is good. So we win some, lose some.
Right. What if a particular observer doesn't want to observe all the observables?
Yeah, so we have a message bus has all kinds of query strings that you can put in, saying I only want these kinds of events. in the general case, there's a whole regular expression like mechanism saying that I, as an observer, want to go and observe this set of this kind of events. I can't even tell you how many papers I saw on this stuff because this was a very hot topic, and then people just got tired of these languages. Okay. Okay. So that's the goal. Let's just see the details. We will no longer go and say trace strings. We will trace objects, and you guys can do this even for your current assignment. Okay, because what I'm telling you is a superset of what I told you earlier. Okay, we are going to go and have these classes that happen to be various kinds of traceables. There is traceable info, there's traceable warning, there's traceable error, there is traceable GIPC info, there's traceable object editor info. You can imagine having a whole hierarchy of information event kinds. That makes sense, right? I mean, these strings should be typed. That's why we have exceptions, that these errors were typed. Why not type all the things we are tracing also? Okay, so this is my user-defined traceable thing. And where I used to do tracer.info, this MVC structure built, I'm going to go to some class. Sorry, I did this in a hurry. I'm going to say MVC traceable info dot new info, a static method, and pass to it a string and some object, which is the object that found that event. Okay, so this is a static method. I need to pass to it some object, and that object is, say, me. So this is really MVC traceable info dot new info or new case. You know, I think I call it. You can name it any way you want to. My convention is to use actually new case, and I've done something different here. And that is going to create an object that is of the event type, and this object is a subclass of traceable info, which happens to be a subclass of runtime exception. And one of the things that you can do to it is announce. So you construct this thing, and then you go and announce and say, look, this event has occurred.
And the announce is just standard print out on the console with an ICE star.
That is one of the options you can have. You announce this, and now the observers can decide what they want to do with your announcement.
Observers who will observe all traceable objects.
Yes, yes. And one of them happens to be something that will print on the console.
Right. But this object doesn't exist until you call it info.
Yes.
So how do you observe something that doesn't exist until it enforces?
Because you give some characteristic of that, saying this thing should have been in this package or this class, or some properties should have.
So you can observe a class and see whenever instances of that class are created. Something like that.
Or you can say anything in this package I'm interested in. So the package can exist before the class can exist, right?
Yes.
So that is what we're going to do. We're going to now observe things and say, you can either say, I want to observe all MVC traceable infos.
Okay, I see. Because there's no direct link, you're just putting something on the bus that says, hey, whenever a message comes through, I guess with regular expressions that matches this package name or this class or some fragment of this class. So you can observe on it even though you don't have you're not actually doing the pattern.
Yeah. And you're observing based on the characteristics of this guy, not the characteristics of this guy. You can do that too.
No, I'm sorry, I lost you.
So there is an object which is a finder.
Yes. What is the finder?
So where I used to put this here,
Yes.
I'm putting this typically here.
Oh, okay.
This is the finder. This is the guy who found that interesting event. This is the observable.
Right.
Whoever found this interesting event.
Okay.
So you are going to go and query based on properties of this guy. You can also do it based on properties of this. I'll show you in the end.
Right.
But that's not as interesting. So this is just the means. The end is this, that, an MVC structure got built, and that class, is something that the observer knows about. Okay? So that's the basic principle. And diagram here. We've got many parties here. Okay? So I've got my traceable with an announce, right? We already seen that. Okay? I've got some event announcer thread, which is the thread that went and made the announcement. Okay? And let's see what happens here. I've got this object, so let's just go back. I've got a little, this is my traceable bus, which is my message bus. We can announce a new event to it, and we can go and register ourselves as listeners. Okay? So this guy, traceable display and wait manager, happens to be a listener that I wrote on top of the bus that goes and adds itself as a listener to all events that occur there. Okay? So far, so good? Okay. Now, some event announcer thread creates a traceable and says, announce yourself. Okay? What's going to happen now? What's it going to do?
It fires a new event to the traceable bus, and that fires it to other listeners.
Good. Level of indirection, that's all it's doing. Okay? Now let's say I want to block at this point.
You just have wait.
So this method does a wait.
Do we have an option not to block?
Yes. Good. Go ask me, I'm feeling better about providing all this big baggage, that you'll see later. So you want an option to not block also.
Of course, you want an option to not block. Blocking isn't deployed most of the time. If you only want to block when you're debugging, you don't want to have all this stuff.
Or when you're demoing. Here we are doing demoing. Actually, I would not recommend this as debugging tool. Debugger is a debugger tool. I would recommend this as a more demoer tool. Okay? So wait for user, and now when will I unblock? So this guy calls wait, okay? And I hit proceed. That goes and calls proceed, that calls notify. Complicated mechanism. Okay.
How does the AWT thread know when to call proceed? How does it know when something is waiting?
Oh, if you just press the button and there was nobody waiting in Java. It will notify no one.
What screen is that button on? Is that just reintroduced?
No, it's when you do the underscore thing. It shows up.
An object editor.
Oh, so-
traceable.
So when you go and do this,
Okay.
you will get this UI.
Let's see.
If you don't do this, you don't have any of this stuff going. You don't have, so if you don't do this, you won't ever block at all. That's the one way to not block is just not to start this. Not to have this listener. This listener is not part of the bus. This is something you add. This guy adds.
Also, if there's no if there's no listeners and it blocks, what then? If there's nothing to
But it shouldn't block if there's not a list.
No. If this itself is not a listener, it's not going to block, right?
Okay, so the manager blocks. I
Yeah,
thought
see,
the
the
bus
manager's
blocks.
new event calls the synchronized wait for user, which makes
Yeah.
it wait.
It's like a little intercept.
Which will also block. I forget what I do. Whether I send these events in. This will. So things will block at that point, but only because this guy in his method blocked that. Okay. So this is really the main idea here is the message bus, which I'm calling a traceable bus because this is a bus that has traceables in it. Has announce method and does not generate events, simply communicates them to observers. Okay, and I'm telling you that this is Steve Rice. I told you from Boston, from Brown University, invented this idea, and then this is way back when SGI was a company and my stocks were worth something. SGI, I had friends in SGI, so I said I didn't join SGI. Every computer company I didn't join, I bought stocks of, saying had I joined the company, I would have made some money. And I just waited till they all went to zero. Till a lot of them went to zero. So, but Silicon Graphics, I had a lot of friends there, and they were implementing this in the software engineering environment, in fact. So the debugger, the compiler, and other programming environment tools with all Eclipse, imagine Eclipse, and especially the programming environment, the compiler, the debugger, all talking to each other through such a bus. That was the first application of it. And I've just applied this to the distributed systems case. Like I said, I've seen many variations of this. And people have gone berserk in the languages they provide, the regular expressions they provide. And I haven't gone there. I've provided you with a very simple language. The same language I provided you for the print. Okay. So we'll just see that UI. So let's say I want to start these three programs in different windows. You've seen that we can do that. And in fact, in the demo application I gave you in GIPC, that's, you can go and fork You can create different consoles for different processes. Something you can do, but you can also go and now say traceable display in weight manager factory dot get traceable da 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 and edit it. And now here's you see what you see here. You're saying set keyword display status this to true. That means some property of mine should be used to go and make events that have the same property as me be displayed in the bus. Okay, so we're going to display these events. We may or may not display these events, and we may or may not, or not wait on these events. Okay, so this guy is a display and wait manager, both. It displays the events, selected events, and it waits on selected events. And how you wait on them is through the same kind of thing where I used to say print status, I say display status. Okay, and I'm giving an object as an argument and saying some property of this object, please use it to determine what is displayed. Okay, and either the class or the package or the toString, just like we saw last time.
No, but where do you specify that?
Somewhere else.
Why somewhere else?
I mean, you can. I'll just show you all the calls later. Okay, that could be set at the beginning. That we want for every guy, we want the packages. We're interested in packages or we're interested in classes. That will be common to everybody. Okay, and each process will have a separate trace window. Okay, so we don't have to worry about one Eclipse region being used for multiple things. Okay, so this is Alice, this is Bob, this is server, and of course if you're running them on different machines, that's not an issue. If you're running them on the same machine, you will get a window like this wherever you went and said object editor.edit factory, the factory, right? So that's clear. Each trace window has a separate thread area also. So just as you have in a debugger, you can select a thread, another thread to go and see the stack trace. I have this thread here, and I have another thread here, and I have different areas in the areas for each thread also. Okay, so thread name, right? So this is the thread interacting with the underlying communication channel. This is the NIO thread, and this is my asynchronous received call invoker. If you haven't figured it out, all of your RMI calls, the remote method calls are invoked by one thread. Okay, and this is that thread. What do we see here? We see the thread name and other information. And the debugger allows you to set breakpoints, resume, etc. So we can similarly, go and say proceed. And if we say proceed, it'll unblock. We just saw that earlier. That same proceed button is being shown here in a context. And if the event is waiting, you'll unblock it. Plus, you can go back and forward and see all the previous events also. Okay? And see the whole trace. But in your demo, all you have to do is proceed. So this is a little extra baggage for the curious and for the demanding. Okay? And so we also we can resume, just like the breakpoint resume, breakpoint console message, go and so this is the, this tells you some type information about the event. Okay, so this tells you, like MVC traceable, this tells you which type of event it is. Okay, and then there's the message. And yeah, so this is just a different type now. And this is the message here, okay? So this was a tracer type defined by GIPC on the left. This is a tracer type defined by us. This is the message, okay? And traceable has, announce, get, and now I can say get stack, and I get the whole stack trace at that point also. Okay, so that's exactly what we wanted because it's a subclass of exception, I get it. So I can see that, look, this was all the calls, and you can see that GIPC has a lot of a big stack. Okay, so no, conceptually nothing different, just the commands, to go and get the information. Okay, and traceable is a runtime exception, like I said. And so I can go and now figure out some of the properties of the object that was sent, and I get to, and I haven't shown you that, but I can just go and say, get me all the properties, and you know object editor will show all the properties of an object. So any properties you have in the object can be displayed in a window at that point. Okay? And you information, so I can go for it. And so now the question is, should I be doing this to all messages? Okay? And may want to pause only some of the announcements, may want to display only some of the announcements, how to specify a set of related announcements, and we just have the same kind of calls that we had earlier. Okay, where I was saying set keyword print status, now I say set keyword display status or wait status. Okay, so nothing, I mean, this is all details. The concept we saw at the beginning. Okay, this is just how to use it. Okay? Okay. And the default is the package name. And I can also go, traceable has a set wait and set display. So if I want only certain kinds of events to be traced, I can just go and override this method and say set display true or set wait true, and that kind of event only will be tracked. So it's the property of the event rather than the property of the announcer of the event. Okay? Questions? The main conceptual thing, that's something I can ask you an exam question.